Hi guys! So today we are going to talk about Le Chatelier's principle. Le Chatelier's principle, also known as Le Chatelier's principle or the equilibrium law. This is how to pronounce Le Chatelier. Le Chatelier. Le Chatelier. But if you can't pronounce it in that way, feel free to use Le Chatelier for now. But please remember that it is really Le Chatelier and not Le Chatelier. This principle states that once a reacting system has reached equilibrium, it remains at equilibrium until it is disturbed by some change of conditions. There are three types of changes that can disturb the equilibrium of a reaction. 1. Changes in concentration. 2. Changes in pressure or volume for reactions that involve gases. And 3. Changes in temperature. The direction of shift can be determined by using the reaction quotient Q and the equilibrium constant, which is Kc. So looking at the photo, Q is increasing from left to right. This means that the values of Q on the left side are lower than Kc and vice versa when it comes to the other side. And Kc, as you noticed, is always at the middle, for it is the equilibrium constant. When Q is lower than Kc, it will have a forward reaction. Remember that Q is increasing from left to right. So in order to meet up or to be equal to Kc, it should move forward. And when Q is greater than Kc, it will have a reverse reaction. Q will move from right to left until its value is equal to Kc. Now let's discuss the three changes. Number 1. Change in concentration. So consider this equation. So based on the equation, this first book represents the reactant side, A plus B. And this second book on the other side represents the product side, C plus D. So in this case, they are in equilibrium for they have the same number of books. Their ratio is 1:1. Now if we increase the concentration of the reactants by adding 2 books, the reactants will be heavier than the product side. For the concentration is changed, they are not in equilibrium anymore. Now in order to bring them in equilibrium again, we need to transfer things. In reality, we tend to transfer things from the heavier side to the other side in order to balance them. And this is what will happen in this scenario. So like in reality, we will transfer things from the heavier side to the other. So forward reaction is favored, which is left to right. And if we increase the product side, it will be from right to left. A reverse reaction is favored. Number 2. Change in pressure or volume. Pressure and volume are inversely proportional to each other. This means that if we increase the pressure, the volume will decrease. Or if we decrease the volume, the pressure will increase. And if we decrease the pressure, then the volume will increase. Or if we increase the volume, then the pressure will decrease. So why is it that they are inversely proportional? So this part represents the volume, and pressure will be applied to this area. Remember that pressure is an applied force to something. So if I increase the pressure by pushing this, notice that the volume decreases. And if I decrease the pressure by pulling, the volume will increase. Now let's take 2 injections. These two are in equilibrium state for they have the same volume. So same with concentration, reactants at the left side and products at the right. If I increase the pressure or decrease the volume at the left side, the product side will be favored. So in order to bring them back in equilibrium, the products should react to form the reactants. Or based on the scene, they have to share some of their water to the other. so it's a reverse reaction. And our forward reaction will occur if you decrease the pressure or increase the volume. Number 3. Change in temperature. Exothermic reaction releases heat. Endothermic reaction absorbs heat. So if we are having an endothermic reaction, either the reactant side will decrease or increase in temperature, while exothermic will be on the other side, which is the product side. So if we increase the temperature at the left side, it will be hotter than the right side, so it should transfer some heat. So this will be a forward reaction from left to right. A forward reaction will also occur if we decrease the temperature on the right side. Now, if we increase the temperature at the right side, it will be favored than the left side. So same with the first example, it should transfer some heat. So a right to left reaction will occur, and this is the reverse reaction. So here is the summary of all the changes. Thanks for watching!